Hi, welcome back. So this time let's gonna have a very interesting sample problem. So we say we have to integrate dx all over the square root of 27 plus 6x minus x squared. Okay, so as you can see here, um, we are not directly on the form of our main formula that yields to the inverse trigonometric function. So by analyzing, what do you think is the most or the nearest formula that we can adopt in order for us to solve this problem, this kind of problem? Okay, say we have a square root sign, so maybe we can adopt the first and the third, but we don't have the u, or say here some function. When we say u there nga pala in our main formulas, u symbolizes there as the sum function of your variable. Say for our example, we use variable x, so u in this main formula is some function of x. Okay, so in our third formula we have function of x outside the integral sign, but in here we don't have. So maybe we are more I mean we can maybe we can use the first formula, which is, let me rewrite our first formula in a much bigger font. So we have du all over square root of the constant that is being squared minus the some function that is also being squared, and that is equal to the arc sine of u over a plus c. Okay, so our challenge is that how can we transform our integrand into this form? Okay, so we have the square root sign, also do have the square root sign, and we need some constant that is being squared and some function of x that is also being squared. So let us try to manipulate this term inside our square root sign. So we have 27 inside our we have 27 plus 6x minus x squared. Okay, so we need some function of x that is being squared, and as you can see here, we have from our inside the square root sign, we have 27 plus 6x minus x squared, and the function of x there, maybe we can find between these two variables with x here, which is positive 6x minus x squared. And if we go back and we do the completing of squares, since we have the square here, maybe let's try to use since we need the square, no? So we need since we have x that is being squared, so we have maybe we have some value of x here, and then since we have 6x here, then think of a number that might result with 6x if it is being squared. So maybe we have a positive 3. Okay, let's try this one. So if this is our f of x, or our u, then in our main formula, in order for us to follow our main formula, it must be multiplied by some negative value here. So let's multiply it by negative sign. Then let's try to expand this form in order for us to check if we were gonna come up to our main or to our uh, original function, okay, which is 6x minus x squared. So we have, let's have negative sign there. We have just this one, this negative sign. So we have negative, we have x times x, or x squared, we have x squared. Then 3x times 2, we have plus 6x. And then 3 times 3 is plus 9. Okay, so if we expand this, we have this x squared plus 6x plus 9. And if we distribute the negative sign, we have negative x squared minus 6x plus 9. Okay, and let us go back to our original function inside the inside the square root sign. So we have negative x squared, so we have that, but our 6x here in our equation is positive, so we have negative 6x there. Then we have some additional constant there that is not equal to 27. So let us fix first this one. So since we have negative 6x here, so maybe try something here that might lead up with some positive 6x there. So maybe let's try to use negative sign here. Okay, so try to use equal to, once again we need the negative sign, so we have negative sign, and then we need some function of x that is being squared. So we say that the x plus 3 is not what we are looking for. So let's now try what if we have x minus 3, because this will lead to some x squared and some value of 6x here. But our problem at first is that the 6x is negative. So let's try if we change the sign of negative 3. Okay, so let's try to expand this f of x here, or u. Let's try this to expand. So we have x times x squared, to negative 3x times 2, we have negative 6x, and then negative 3 times negative 3, we have positive 9. Okay, so the expanded form of this is x squared minus 6x plus 9, right? And then we're gonna multiply this whole term by negative sign. So we have negative x squared, and negative times negative, we have positive 6x, and then negative 9. Okay, so let us analyze once again. So we have positive negative x squared, so we have negative x squared, positive 6x, we have positive 6x, and then we have here 27, but here we have negative 9. So we need to add some value, some constant, in order for us to equate this form into our original function, which is 27 plus 6x minus x squared. Okay, we already solved the negative x squared, we already have this positive 6x, but we are left with negative 9 here plus some value. So using algebra, you can now think of a number that is equal to negative 9 plus this some unknown number in order for you to come up with 27. Okay, then by doing the algebra, we have 27 then plus 9 is equal to that number, which is equal to 27 plus 9 is 36. So we need to add 36 here in order for us to complete our form that is equal or equivalent to our original function. Okay, so finally we can rewrite this as we can rewrite this as the integral of dx all over the square root of negative x squared plus 6x minus 9 and then plus 36, wherein this part is, we said that it is this part. Okay, so we can further simplify this as I have the square root of let me write this first, 36, and then minus x plus 3 squared. Did you follow? Okay, so we say that this whole term, our original term, can be expressed using this one, and we further simplify this by having not that one but this one, by having this one. So we need to erase this because that is not what we want, but we want the negative 3 x minus 3, which leads to this one. Again, this one is equal to negative x minus 3 squared. Okay, so as you can see here, you can now easily see that we are now near on our main equation or main formula, which is equal to a squared minus u squared. Okay, so as you can see here, you can now easily think that 36 is just equal to the 6 times 6 or 6 squared. So our value of a here is just 6. So we have dx square root of our base constant here is 6 squared. Then once again, 6 squared is just equal to this 36, then minus the function of x, which is x minus 3, and then squared. Okay, wherein the derivative of x is just dx. So we can now apply our main formula, which leads to arc sine u over a plus c. Our arc sine u is x minus 3, and then our constant a is 6, then plus 3. There you have it. So our final answer is just arc sine x minus 3 all over 6 plus c. Okay, that is an example of integration yielding to inverse trigonometric functions. So I hope you learned something from this, and it is a very interesting problem. But all you need to do is to do some algebra in order for us to come up with our main formula, and then if you are already on the form of our main formula, then you can now directly use it and then come up immediately with our answer. Okay, so thank you, and see you on